Hello, everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
So last time, where were we? Yeah, we first defined a function to get the divisors of a natural number, and then applying it, we found a way to get common divisors and multiples, especially greatest common divisor and least common multiple. Okay, let's quickly check the code and then do the homework. Okay, open E3, connect. And what we were doing was like given two numbers, how to define, say, GCD and LCM. Okay, so let's, what we need factors function first. Where are we? Where is it? Factors. Okay, factors, two versions of factors. We will use the shorter one. And then we can define GCD here and maybe LCM here. Okay, let's quickly do the homework. So first one was GCD 77 and 119. Okay, so GCD 77, 119. So what we get, it is 7, naturally. Okay, we can check that one likewise. Well, 77 is apparently 7 times 11. So what we get if we get what if we divide 119 by 7, it's 17 is another prime number. So the GCD is 7. Okay, what's next? Likewise, okay, what we get is GCD of 3103 and 4387. Okay, simple. 107. Okay, let's check. 107 is like 29, another prime. 4387 divided by 107 is 41. So it's kind of very complex prime number factorization. So maybe the best way to find the answer by hand is use Euclid's algorithm. I hope you know no, sorry. Yeah, Euclid's factorization method. Okay. So what is LCM or both? Of course, naturally, it's easy. So it's LCM. LCM doesn't print. LCM doesn't print anything. Sorry, it's strange. Why? Why it doesn't print anything? This CD will return 9. LCM or starting, maybe this is bigger than that. So to make sure that we have that number, maybe we can change it. While true, so n equals the maximum of the 2, comma, if, so we don't need it. So if n is divisible by 2, otherwise, well, we don't need else here because, okay, n increment by 1. Okay, so this will actually do the same work and return does work for all numbers. Okay, so let's the answer. Okay, it returns 127,223. So So what happens if you divide this 41 and the prime and 4387? Okay, that's correct. So maybe this number can be decomposed into the 107. Okay, common GCD times 41 times 29 equals this number. Okay, great. So we could check that. Please stop the video and check yourself that this is correct. Okay, so let's go on to today's work. List related basics. So we learned some more knowledge about lists because it's a very important fundamental data structure in many programming languages, including Python. Okay, you can add and multiply lists. Okay, so for example, let's see a list, one list, which is factors of 12. Okay, let's check. L1 is apparently 1, 2, 3, 4, 6, and 12. Actually, you can add L1 plus L1. Oh, what do we get? It's just a concatenation of two lists. So the first half is L1 and second half is also L1. So just to concatenate. Or this can be written as times 2. The same thing. Okay? So you can guess what we get if you write times 3 like this. Or even, for example, let's define L2 as, say, factors, what is it? 18? Okay. Then, of course, L1 plus L2 is, yeah, the first half is factors of 12 and the second half is factors of 18. Or even you can change L1 by adding L2. And then you can see what L1 now is. Okay, so now L1 has changed to the sum of L1 plus L2. Okay, can you see that? Okay, it's non-reversible. Okay, so you can do this. Or L2 times 2. And this will produce L2 plus L2 as L2. Okay. So this is what I mean by you can add and multiply lists, making or initializing a list of all zeros and ones. Suppose we want a list of length 10 consisting of all zeros. In that case, you can get by likewise multiplying list of 0 10 times. Okay, right? Likewise, if you want a list of length 12, all consisting of ones, you can do like this. Okay? Making a list of natural numbers up to 9. Maybe you already know this. Yeah, you can use it. You can make it by list comprehension. So for any k for k in range 1, 2, what was it? Up to 9. So I should write. So this will produce what we want. 1, 2, 3, 4, 5, 6, 7, 8, 9. The length is, of course, 9. Okay. How about 21 through 29? Okay. You can do it, right? Yes. One way is, of course, writing. Okay, let's call it L1 this time. L this time. Okay. So we got L like this. One way is using this, just like, yeah, is 21 to 30. This is one way of making it. But Another way is using L. Yeah. Another way is just like, yeah, K plus 20. And we'll produce the same thing. Or using L, you can do, for example, N for N. Okay, N plus 20 or N in L. This will be the same. Okay, so here, L, from L, element is taken by one by one as N, and list of N plus 20 is obtained as list using a list comprehension. This is basic. Please be familiar with this kind of technique. Okay. Sum of 1 to 10. Can you do it? Of course, one way is using my sum. Go 0. And then for n in range, what was it? 1 to 10. So 1 to 111. And then my sum equals n. Okay. And print my sum. This will, of course, we can get the result of 55. But the other way is make a list of 1 through 10. Right? This is it. And then applying an operator sum to this, we'll get the same summing result. Okay? So be sure to know the operator sum applying to a list will produce the sum of all answers. Okay? And the average of 1 to 10. You know how to calculate the average. Sure. It can be calculated by dividing the sum by the number of elements. Okay, so maybe we can copy this and call it L. Then we can calculate. Maybe we can. Okay, but sum of L divided by and length of L. Okay, this will produce the average number from 1 to 10, which is 5.5. Of course, it's 55 over 10. Okay. Okay, that's all for today. Now you're familiar with many techniques related to lists. Of course, there are many. Actually, yeah, but you can check that yourself. Okay, homework. How about the sum and the mean of 1 through 100? So easy. And I hope you can find a story about the genius Friedrich Gauss. Okay, I hope you'll come back next time. So have a good time. Bye bye.